Hi guys, this is a video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you're looking for elsewhere. There is a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today, we are going over lesson 2.2, negative numbers. More specifically, how to write negative numbers, their opposites, what you can use negative numbers for, where they are on number lines, and how to write inequalities with negative numbers. We are not going to be discussing how to add, subtract, multiply, or divide them. That is a 7th grade standard. All right, so we have two vocabulary terms. Our first one being negative number. Negative number is a number that is less meaning smaller than 0. A number that is smaller than 0. Our next term is opposite. Opposite means having the same numeral but a different sign. So a couple quick examples of this would be, let's say I have positive 4. It is the opposite of negative 4. So we have the same numeral, but a different sign. On this one, we have a negative sign. On this one, well, we don't see a sign. Anytime we write our numbers like this, it's understood that it has a positive sign in front of it. We just typically don't waste time doing that. So it's always understood to be positive unless, of course, you have a negative sign in front of it. Another quick example, let's say I have negative 23. Well, it is the opposite of positive 23. And again, I do not need to write the plus sign in front of it. It is understood that it is positive if I do not have anything in front of it. So same numeral, but different sign. One's negative, one's a plus or positive. And the positives are optional. Okay, so positive and negative numbers can be used to represent many different real-world situations. A very common use for them is to represent temperature readings above and below 0. When you have a temperature reading above 0, you have a positive number. If you are dealing with temperatures below 0, you have negative numbers. So here's a simple scenario of midnight and the temperatures all the way to 4 p.m. And we're going to practice going back and forth between numbers and how you write them in words. So let's say it's midnight and you're in a super cold place and it happens to be negative 5 degrees Celsius outside. Don't forget, when dealing with Celsius, 0 degrees Celsius is freezing. So we're a little bit lower than freezing, right? Super cold. Okay, how would I write negative 5 degrees Celsius in words? In words, I would say that is 5 degrees Celsius below 0. Why? Because it's a negative number. Negative numbers, when dealing with temperatures, are referring to the fact that it is below 0. Okay, 4 a.m. So 4 hours later, the sun has not come out yet. Still super cold. Actually, it's getting colder. In words, let's say someone says it's 12 degrees Celsius below 0. How would I write this as a number? Well, because it's below 0, it's going to be a negative number. What's my number? 12 degrees Celsius. So 12 degrees Celsius below 0 is written as negative 12 degrees Celsius. Okay, let's flip back and forth. So It's 4 hours later. It's 8 a.m. The sun is starting to come out. It's actually getting a little bit warmer. And the temperature says -8 degrees Celsius. It hasn't really gotten much warmer, has it? Okay, how would I write that in words? Well, because it's negative, that means it's below zero, super, super cold, below freezing. So I would write 8 degrees Celsius below zero. All right, it's 12 p.m. So a few hours later, it's getting warmer. The sun's been out for a while. It is, well, let's say we say it's 4 degrees Celsius outside. Oh, it's finally above freezing. How would I write that in words? Well, because I don't see any negative sign, it's implied that it is above zero, so warmer than freezing in this case. So I would write 4 degrees Celsius above zero. All right, last example. Let's say I have in words, someone says it's 10 degrees Celsius above zero. How would I write this as a number? Well, because it's above zero, that means it's going to be positive. So I simply write 10 degrees Celsius. I could write the positive sign if I wanted, the same on the 4 degrees Celsius. However, positive signs are not necessary. Okay, 3 quick questions. Which one is our lowest temperature? So I have -5 degrees Celsius, -12, -8, +4, and +10. Now, when dealing with negative numbers, it's very useful to think of them as temperatures because the colder it is, the lower the number really is. So I know 12, you think, well, 12 is the largest number on here, but that's not actually 12. That is -12. That means it's 12 below zero. This is 5 below zero. That's 8 below zero. This would be 4 above zero and 10 above zero. So which one's the coldest? Well, it would be this temperature right here. That's what I call nope, not going outside. So -12 is your lowest number. -12 degrees Celsius, that is. You always have to have your label. Otherwise, you don't know what you're talking about. You could be talking about -12 unicorns. First of all, unicorns don't exist, but that just doesn't make sense. So, -12 degrees Celsius is your lowest number. Why? Well, that would be our coldest temperature. It's also the farthest below zero if we were drawing a number line, which we're going to get to in a little bit. Our next question, which one is the highest? So, when dealing with temperatures, and you want the highest, think of which would be the warmest. Well, our warmest temperature would be the 10 degrees Celsius, or the 10 degrees Celsius above zero. So basically, you're 10 degrees above freezing. So this is going to be your warmest. So this means 10 degrees Celsius is your highest number. All right, which one's closest to zero? So this would be 5 below zero, so that's only 5 away. This is 12 below zero, so that's a little bit farther, right? So definitely out of the running. 8 below zero, well, 5 below zero is still closer to zero. It's only 5 away. This one's 8 away. Okay, 4 degrees Celsius. That's 4 above. Well, 4 above zero is only 4 away from zero, where this is 5 away from zero. So 4 so far is the winner. 10 degrees Celsius. Well, that's 10 above. So 4 degrees Celsius is closest to zero. It's only 4 away. Now, one thing, when looking at negative numbers versus how they're written in words, especially with temperatures, notice I have -5 degrees Celsius, but when I'm writing it in words, because I wrote the below zero, I do not write those negative signs on anything. Well, definitely not these, because these are above zero. They're positive. Our next use for negative numbers. They can be used to represent gains and losses. Gains implies positive numbers. Losses implies negative numbers. So 2 examples. Our first, let's say someone says we have a loss of 15 yards in football. Where else would you lose 15 yards? Yeah, probably in football. And we want to write this as a number. Well, first, we're going to look at our keywords like loss. That means negative. And what's my number? 15. And what's my label to go with it? Yards. So we're going to write negative 15 yards. So a loss of 15 yards in football would be represented by negative 15 yards. So this is my number. Again, always make sure you have your label, otherwise no one will know what you're talking about. Next example, let's say we have a gain of 30 yards in football. And we want to write that as a plain old number. Well, gain means positive. And again, on positive, I don't need to write the plus sign. I could. What's my number? 30. What's my label to go with it? Yards. So a gain of 30 yards would be positive 30 yards. Now again, this could be represented as plus 30 yards. By the way, the abbreviation for yards is YDS. Okay, our next use for negative numbers. They can be used to represent levels above and below sea level. So above, just like temperatures, represents positive numbers or indicates positive numbers. Below sea level indicates negative numbers. Now sea level. Sea level would be like if you're standing right at the ocean, you're not above the ocean and you're not below the ocean. So technically you're at 0 feet. You're 0 feet above the ocean. You're 0 feet below the ocean. So sea level is usually referred to as 0 feet. So sea level is 0 feet. And you're either going to be so many feet above the sea level or so many feet below. So a couple examples of using negative numbers in this way. Our first one is, say you have a valley and it is 52 feet below sea level. Now you might be asking, how can a valley be below sea level? Well, you can have valleys in the ocean, but sea level is just where the ocean is in relationship to your land. So think of places like Louisiana or New Orleans specifically. New Orleans is actually below sea level. The whole city is below sea level. What keeps it from flooding? Well, they have levees and other structures that keep the water out, but they are technically below sea level. And places farther inland can be below sea level because the land, it has its ups and downs from weathering, erosion, and other different processes. So anyways, we have a valley. It's technically below the sea level. So if it was at the ocean, yeah, it would be underwater. We want to write this as a number. So first, let's look for key terms. It's below. That means I have a negative number. What's our number? 52. What's the label? Feet. So 52 feet below sea level would be negative 52 feet. Another quick example. Let's say you have a mountain. Mountain doesn't, well, never mind. Hold on. Mountain is, getting a little too excited, 7,310 feet above sea level. All right, so you might be thinking, well, a mountain has to be above sea level. No, you can have mountains underwater. They exist. But anyways, this mountain happens to not be below water. It's above sea level. So think of Mount Everest, definitely above sea level. So we have a mountain. It's 7,310 feet above sea level. That means we're going to write a positive number. So I could write the plus sign if I wanted, or just not put it at all. Then I'd write my number and label 7,310 feet. So this number right here represents an elevation that is above sea level. Okay, one more use for negative numbers. They can be used to represent debits and credits. So debits refers to how much money you owe. How much money you owe. So if you know anyone that has a debit card basically whenever you go shopping, you swipe your card and money is subtracted from the bank. So debit means loss or takeaway or negative. Now the opposite is true for credit. Credit means how much money you gain. Don't be thinking of credit cards. Different. So credit is how much money you gain. So positive numbers. All right, here's a couple examples of them being used. First example, let's say you use your debit card and you spend $180 at the store. Well, the bank is going to, if you look at your bank statement and you know all of your purchases and your history, there's going to be something on there that says perhaps a debit of $180. It might not actually say debit of $180. So what would it actually look like? Well, you're going to see them taking away $180. So a debit of $180 means negative $180. It's going away, and then you're very sad because you have no more money. Another example, credit. Let's say the bank says you're getting a credit of $79. Credit means you're gaining it. You're getting it. You're getting it back. Maybe you paid too much money on something and they're giving you more money back. So credit means positive, so I don't need to write a positive sign unless I want to. And then I write my number and label. So $79. This would imply a credit. You're getting $79. Then you're much happier. Not as happy because you've already spent $180. All right, next. Negative numbers can be represented on number lines just like positive numbers, like our one of our previous lessons. They can be on horizontal or vertical number lines. On a horizontal number line, negative numbers are placed to the left of 0. Positive are going to be on the right of 0. So notice our numbers seem to have an opposite effect. Traditionally, we're used to dealing with positive numbers, and our numbers get bigger as they go farther right. Well, let's go ahead and jot that down. Numbers get bigger as they go right. So your numbers get bigger as they go right. Now what happens when you go left? Well, your numbers get smaller. Now when you look at these numbers, -1, -2, -3, -4, -5, you might be thinking, well, no, they're getting bigger. No, that's not a 1, it's a -1. You are 1 below 0, which is small. Like so small, it's below 0. It's less than nothing. -2, 2 below 0, like even smaller. -3, again, that's not a 3, that's a -3. So you're 3 below 0, even smaller. I like to usually think of negative numbers as temperatures. So I would say, okay, which one of these temperatures would be colder? Well, -5 would be super, super cold. -1, sure, super cold, but not as bad as -5. So I know the numbers look like they're getting bigger, but these have negative signs in front of them. So it's like an opposite effect. Again, as you go left on a number line, the numbers are getting smaller. So what is the smallest number on this number line? -5 would be the smallest. +5 would be the largest. Okay, on a vertical number line, negative numbers are placed below 0. So here's our example. Here's 0, negative 1, 1 below, negative 2, 2 below, negative 3. Our numbers keep getting smaller. So which one is the smallest? Negative 5 is the smallest. If I go further, those are going to be even smaller. Going in the opposite direction, you have your positive numbers. As you go up on a vertical number line, the numbers get larger. Again, the numbers have an opposite effect. I know this looks like a 5, but it's not a 5. It's a negative 5. That's 5 below 0. So negative 5 is smaller than negative 4. Negative 4 is smaller than negative 3. Negative 3 is smaller than negative 2. Negative 2 is smaller than negative 1. Negative 1 is smaller than 0, which is smaller than 1, and so on. Okay, I've been mentioning the opposite effect. Well, that's our next topic. Every positive number has a corresponding negative number. These are called opposites. Opposites are the exact same distance from 0. So let's look at this last example here. Opposite of 3. So if I find 3 on this number line right here, this vertical one, it's right there. Well, opposites are the same distance from 0. So how far is 3 from 0? Well, it's 1, 2, 3 away. So same distance, 3 away. Let's go on the other side. 1, 2, 3. 3 away, we have negative 3. So the opposite of 3 is simply negative 3. Now, if we remember our definition of opposite is having the same numeral but a different sign. So if you look at this, we have 3. We have the same numeral, but now we have a negative sign instead of a positive. Now, I don't see a plus sign. That's because you do not have to write the positive signs in front, or the plus signs. Okay, let's do the others super quick. 22, it's a positive. So opposites have the same numeral, but a different sign. This is positive, so the opposite will be negative. It means both of these numbers are both 22 away from 0. One's 22 below 0, one's 22 above. Next one, negative 32. It's got a negative sign. So the opposite would be 32, and you could write the plus. So you could write 32 or positive 32. Same thing, but when you have positive numbers, you do not need to write the plus sign. Next, and last, negative 5. Opposite, we need the same numeral, opposite sign, so the opposite would be positive. So I could write 5 or plus 5. Same thing. We typically, again, don't write the positive signs. It's just a waste of time. Okay, let's move into number lines. We're going to draw a horizontal number line to represent numbers from 0 to 6. And we're going to do the opposites. So, first step, horizontal number line. We're going to need all of this room, like all of it. Like just fill it up. Now, I want numbers from 0 to 6. So if I were to do 0 to 6, I would want 0, 1, 2, 3, 4, 5, and 6, right? And I want to represent the numbers from 0 to 6. From means all of them. So which ones are from 0 to 6? That one, that one, that one, that one, that one, and that one, and that one. 0 to 6. That would be from 0 to 6. Now I'm not finished, because I also want their opposites. So what's the opposite of 1? Negative 1. What's the opposite of 6? Negative 6. And then I would fill it in. Be sure, whenever you're doing negative numbers on a number line, be careful, because, again, it has this opposite effect. You might be tempted to count a little differently. So this is negative 1. I need to put negative 2. Now, let's say you were going backwards, and you were going from negative 6 and trying to get back to 0. You might be tempted to put negative 7, negative 8, negative 9, negative 10. Well, are we ever going to get to 0? No. So Remember, negative 6 is the smallest. What's bigger than negative 6? Negative 5 is bigger because it's closer to 0. Negative 4 is bigger. Negative 3 is bigger. I have a gap. I don't like it, but bigger than that is negative 2. Larger is negative 1. Larger is 0. And you keep getting larger as you go right. All right, we need dots on all of these because it says from 0 to 6 and their opposites, meaning every single one needs to be represented. Next example, we're going to draw a horizontal number line to represent opposites of whole numbers from 20 to 30. So we do not want 20 to 30, do we? We want the opposites. It doesn't say like 20 to 30 and their opposites. No, it just wants the opposites. We don't care about 20 to 30. We just want their opposites. So what's the opposites of 20 to 30? That'd be negative 20 to negative 30. Okay, first step, your horizontal number line. All right, next step, I need to determine my smallest number and my biggest number. Again, negative numbers have that opposite effect. They can be really confusing when you're first learning them. So I want you to think or always picture a number line like this, short and sweet in your head or your horizontal one. Think 0 is in the middle of your positives and negatives. Negative 1 should be the closest to 0, meaning negative 1 is your largest, biggest negative number. And they get smaller as you go left. Even though they look like they're getting bigger, they're not. So if I'm looking at negative 20 and negative 30, and I want to know which one is the biggest, I might think it's negative 30. However, which one's closer to 0? Well, if I did negative 1, negative 2, negative 3, negative 4, negative 5, I'm going to get to negative 20 first. So negative 20 is the closest to 0. It's 20 away from 0 if I kept on going in the right direction. Negative 30 is over here on the left. It's 30 away from 0 if I kept on going. Now, since I have my numbers, it should be easier to count by. Again, be careful. So if I'm going backwards, we wouldn't want to do negative 31 because I'm never going to get to 0 that way. I need to do negative 29, negative 28, negative 27, negative 26, negative 25. We're getting larger. Negative 24, negative 23. Again, we're getting larger and larger. Negative 22 and negative 21. And then negative 20 is the largest on this line. If I kept on going, negative 19, negative 18, negative 17, I'm eventually going to get to 0. Okay, which ones get dots? I want to represent from, well, technically the opposites, negative 20 to negative 30. That means all of them because it has the word from. It doesn't say evens, doesn't say odds, not between. We want from this to that. All right. Our next example, we're going to draw a vertical number line to represent even negative numbers from negative 8 to negative 2. So it's got vertical, we want even, and we want from negative 8 to negative 2. So first step, you want your vertical number line. We're going to do this twice to show you two different possible answers. First step, we need, or after, so second step, to put our end numbers, negative 8 and negative 2. Let's think, which one is larger? Again, when you're dealing with negatives, the opposite of what you're used to is probably going to be true. Also, we need to always, again, picture a little number line. 0 in the middle, think positive, above, negative, below. So always have this memorized, kind of ingrained in your head. So how is this going to help you? Well, we know if I see like negative 2 right there, that means if I go smaller, it's going to be negative 3. Smaller is negative 4. Smaller is negative 5. Negative 6, negative 7, negative 8. So that means if I'm dealing with negative 2 and negative 8, negative 2 is my largest number. It's closest to 0. Negative 8 Is 8 below 0? It's my smallest. So negative 8 is smaller. Negative 2 is larger. Okay, now, why do I have two different lines? Well, one is for the people that just want to be done with this, because math is not their thing, we just want to be finished. And the other is for the people that want to take their time. So let's do the one that wants to take their time first. So they're like, all right, negative 8, how do I get to negative 2? Well, they would say negative 7 is larger, negative 6 is larger, negative 5 is larger, negative 4 is larger, negative 3 is larger, and negative 2 is the top. Which ones get dots? I want the even ones from negative 8 to negative 2. So negative 8, negative 6, negative 4, and negative 2. The evens from this one to that one. So this is one possible answer. Now, this is for the person that just wants to be finished. They're like, okay, I only have to do evens from negative 8 to negative 2. So, shortcut, negative 6, negative 4, negative 2, done. And we put the dots. So I want the evens from negative 8 all the way to negative 2. So these are the four most important numbers. The question wants to know, do you know which numbers are even from negative 8 to negative 2? It would be these four specific ones. Okay. Next, we're just going to use number lines to help us compare negative and positive numbers. And we're going to use just this picture of this number line to help us. Now, typically when comparing them, if you just have typical whole numbers or integers that are negative or positive, you're not dealing with fractions or decimals with different denominators or anything else, there's no work to show. However, it's very helpful to be looking at a number line when comparing negative numbers and positive numbers, determining which ones are less than or greater than. Okay, our first example. Negative 10, negative 12. Well, let's look at them on a number line. If I looked at negative 10, it's right there. Negative 12 is right there. Which one is farther to the right, meaning bigger? Well, negative 10 is farther to the right, so negative 10 is larger. So I'm going to say negative 10 is greater than negative 12. Now, I'm going to explain on the notes. If this was a typical problem, you would be finished. There would be no explanation needed. But we're going to explain. Why is negative 10 larger? Because, we're used to 10 being, smaller than 12. But again, that's not 10. That's negative 10. It is because negative 10 is farther right on a number line. Okay, our next example, negative 6 and negative 9. Negative 6 is right there. Negative 9 is right there. So negative 6 is farther to the right. So that means negative 6 is larger or greater than. Why? Again, because negative 6 is farther to the right. Okay, next example. Negative 8 and negative 5. Negative 8 is right there. Negative 5 is right here. Negative 8, negative 8 is further to the left. So negative 8 is less than or smaller than negative 5. Again, why? Again, because negative 8 is farther left on a number line. Horizontal, to be exact. Last example, we have 1 and negative 4. Positive numbers are always larger than negative numbers, but we're going to explain a little differently. So we've got positive 1 right there, negative 4 right there. Numbers farther to the right are larger, so that means 1 is greater than negative 4. Why? Because 1 is farther right. All right, we've got just a few more examples. So we're going to continue with inequalities. But now we're going to compare different numbers in different contexts, such as temperatures. So we have a table, and it shows the lowest recorded temperatures in Alaska for each month from July through December. And we are dealing with Fahrenheit, or degrees Fahrenheit. That's important because you always have to have labels on your numbers, otherwise no one knows what you're talking about. So July, 16 degrees was the lowest recorded temperature, August, 8 degrees Fahrenheit, September, negative 13 degrees Fahrenheit, and so on. Our instructions are, use an inequality to compare the month's low temperatures. So the first one, we're going to compare July and August. So we're going to keep that order. So first is July. July is 16 degrees Fahrenheit. So we're going to write 16 degrees Fahrenheit. Next is August. August is 8 degrees Fahrenheit. Now we're going to compare them with an inequality symbol, so greater than or less than. Now, because both temperatures are positive, meaning above zero, you simply look for the larger one, or the largest one, and there's no confusion because there are no negative numbers. 16 is 16 above zero, 8 is only 8 above zero, so 16 degrees Fahrenheit is greater than, or larger, or warmer than 8 degrees Fahrenheit. Our next example, September and December. September is negative 13 degrees Fahrenheit. December is negative 72 degrees Fahrenheit. Okay, we have two negative numbers. Remember, when dealing with negative numbers, and you're just beginning with them and learning them, they seem to have an opposite effect. You might be like, well, 72 is larger. No, this is not 72. This is negative 72. This is 72 below zero, like super cold. Like nope, that's a nope temperature. We don't go outside when it's that cold. We don't go outside when it's that cold either, but negative 72 is worse, right? It would be colder. Also, if you're thinking of your number line, where would negative 13 be? Well, negative 13 would be right here on this number line, actually. Where would negative 72 be? Well, negative 14, negative 15, negative 16, negative 17, and I'd have to keep going left. That means negative 72 is colder or smaller or lower than. So we're going to say negative 13 degrees Fahrenheit is greater than negative 72 degrees Fahrenheit. Again, it's helpful when you think of temperatures, because the colder one, well, negative 72, yeah, definitely super cold. That's not as cold. I could survive that. Next example, September and August. September, negative 13 degrees Fahrenheit. August, 8 degrees Fahrenheit. Yay, above freezing. Well, no, never mind. We're dealing Fahrenheit. Done messed up. All right, Fahrenheit, 32 degrees is freezing. Okay, which one is smaller? All negative numbers are on the left of zero. All positive numbers are to the right of zero. So that means negative 13 degrees is smaller than, or less than, or colder than 8 degrees Fahrenheit. Okay, this one is bolded. Why? Because the directions have slightly changed. We're going to compare the temps of November and July, but we're going to do a sentence. So it's almost going to look like this, but instead of inequality symbols, we're going to use words that represent the context, like colder than or warmer than, instead of these symbols. So first step, we'll write our numbers like we have been. So November is negative 61 degrees Fahrenheit. We're going to leave extra space for our sentence. All right, July is 16 degrees Fahrenheit. And now I'm going to fill it in with the appropriate words. So negative 61 degrees Fahrenheit. That's going to be a much smaller number. It's 61 below zero, where 16 degrees Fahrenheit is above zero. Since we're dealing with temperatures, we're going to use words like warmer than or colder than. So in this case, we're going to say negative 61 degrees Fahrenheit is colder than 16 degrees Fahrenheit. So we compared them using a sentence versus an inequality. So this is your sentence. These are inequalities. Always make sure you're looking at the instructions for whatever you're dealing with. Okay, we have one more example. All right, this table shows the elevations, so that's how high or how much higher or lower you are compared to sea level, which is at 0 feet. We've got Death Valley at negative 282 feet. We've got this lake at negative 509 feet, and Driscoll Mountain, Louisiana at 535 feet. Our question says, compare the elevations of Death Valley to this lake with an inequality and a sentence. So let's jot down 2 spots for our answers. So we're going to have an inequality, and we're going to have a sentence. Okay, let's jot down our information. Death Valley, it is negative 282 feet. The lake is negative 509 feet. First, inequality. We're going to write down our numbers with labels. Now we need a greater than or less than symbol. Think, negative 282 feet is 282 feet below. Negative 509 feet is 509 feet below. Below what? 0. That means this one is farther below 0 than this one. That means negative 282 feet is the bigger number. It's closer to 0 on a number line. Negative 509 is much farther away. They're both negatives. So again, always be imagining this little bit of a number line. So if I thought, all right, which one of those numbers is going to be higher up on a vertical number line? Negative 282 is going to be higher up. Negative 509 is going to be way farther down. Okay, next, I need a sentence. So same setup, but instead of an inequality symbol, we're going to use context words, or words that fit the context. We're dealing with elevation, or above or below sea level. So we're going to use words like higher or lower. So we're going to say negative 282 feet is, well, since it's a greater than symbol, we're going to say is higher than negative 509 feet. So we're trying to use words that fit our context. Our context is elevation, or how much higher above sea level you are, or lower than sea level you are. Just like with temperature, we use words such as warmer than or colder than. Okay, I hope this has helped you understand how to write negative numbers, their opposites, as well as putting them on number lines and working with negative numbers and inequalities. If it did not help, I hope you can find a video that will give you what you need. Y'all have a great day.